Are you looking for a step-by-step process in finding the derivative of transcendental function? If that's so, this video is for you. I am ROYALLENE from BSED 3D, and this is my performance task 2 in Calculus 2. In this video, I'll show you how to find the derivative of transcendental function using the chain rule. So, what are you waiting for? Let's start! In our derivative, I use the derivative of sine x, derivative of tangent x, derivative of secant x, and derivative of natural logarithm function. Let's start with problem number 1. Number 1, we have y is equal to sine 10x. Since we're working on the derivative of sine x, we know that the derivative of sine x is going to be cosine u multiplied by du over dx. So we have y prime is equals to cosine u multiplied by du over dx. And this particular functions using the chain rule let u be equal to the value of the inside, which is 10x, and its derivative. Solving its derivative, we will get 10, which is the value of du over dx. If we're going to apply the formula for the derivative function of sine 10x, therefore, y prime is equals to cosine 10x multiplied by 10 is our derivative of sine 10x, which we can simplify or have other version as y prime is equals to 10 cosine 10x. So, this is how we use the derivative formula for sine 10x, and now we use chain rule in the process. Now, let's go ahead and answer number 2. And in number 2, we're looking for the derivative of tangent 5x squared. The derivative of tangent u is secant squared u multiplied by du over dx. So, we have y prime is equals to secant squared u multiplied by du over dx. Let u be equal to the value inside, which is 5x squared, and its derivative. Solving its derivative, we will get 10x, which is the value of du over dx. If we're going to substitute it to the derivative formula, we have y prime is equals to secant squared 5x squared multiplied by 10x. Or we can rewrite it as y prime is equals to 10x secant squared 5x squared. So, this is our derivative function. Now, for problem number 3, we have y is equals to square root of secant 10x. Let's rewrite this into quantity of secant 10x raised to 1/2. So, we can use the chain rule and then the root for finding the derivative of secant u multiplied by du over dx for this function. So, y prime is equals to 1/2 quantity of secant 10x raised to negative 1/2 multiplied by the derivative of the inside, which is quantity of secant 10x. We're finished with the derivative of u to the 1/2, which is 1/2 quantity of secant 10x raised to negative 1/2. We just need to get the derivative of quantity of secant 10x. Wherein we know that the derivative of quantity of secant 10x is secant u tangent u multiplied by du over dx. We're using the chain rule, let u be equal to the value of the inside, which is 10x, and get its derivative. Solving its derivative, we will get 10, which is the value of du over dx. Using the formula, we have secant 10x tangent 10x multiplied by 10. Then, we get 10 secant 10x tangent 10x for our derivative function. Our y prime is equals to the first set, which is 1/2 quantity of secant 10x raised to negative 1/2 multiplied by the second set, which is 10 secant 10x tangent 10x. Then, let's simplify it by multiplying the 1/2 by 10, and we get y prime is equals to quantity of secant 10x raised to negative 1/2 multiplied by the 5 secant 10x tangent 10x. To make this equation or the exponent positive, let's make it as a denominator, and we know that if the exponent is a fraction, it is equivalent to radical sign. That's why we get the final answer, which is y prime is equals to 5 secant 10x tangent 10x all over square root of secant 10x. Now, for problem number 4, we have the derivative of ln or the function in terms of ln. Number 4 is y is equals to ln, quantity of 10x minus 12x cubed. We know that the derivative of ln u with respect to x would be 1 over u multiplied by du over dx. And this would be the equation that we're going to use in finding the derivative of this transcendental function. So, we have y prime is equals to 1 over u multiplied by du over dx. Now, let u be equal to the value of inside, which is 10x minus 12x cubed and its derivative. Solving its derivative, we will get 10 minus 36x squared, which is the value of du over dx. Let's now plug it into the derivative formula. Then we get y prime is equals to 1 over 10x minus 12x cubed multiplied by quantity 10 minus 36x squared. We will multiply 1 by du over dx, which is quantity of 10 minus 36x squared. And we get y prime is equals to 10 minus 36x squared all over 10x minus 12x cubed. Now, we will factor it out. So, we get y prime is equals to 2 quantity of 5 minus 18x squared all over 2 quantity of 5x minus 6x cubed. Then, 2 divided by 2 is 1. That's why we get y prime is equals to 5 minus 18 squared all over 5x minus 6x cubed. And this would be the final answer. For the last number, number 5 is f of x is equals to sine raised to 4 10x. We can rewrite it in terms of f of x equals to quantity of sine 10x raised to 4. So, this is the modified version of trigonometric function where we are going to use a chain rule for the derivative. F prime of x equals to 4 quantity of sine 10x cubed multiplied by derivative inside, which is sine 10x. Since we're finished with the first set, which is 4 quantity of sine 10x cubed, we just need to find the derivative of sine 10x. And we know that the derivative of sine 10x equals to cosine u multiplied by du over dx, where let u be equal to the value of inside, which is 10x, and its derivative. Solving its derivative, we will get 10, which is the value of du over dx. Let's plug it into the equation. So, we have cosine 10x multiplied by 10. Then now, we get 10 cosine 10x. Our f prime of x now is equal to the first set, which is 4 quantity of sine 10x cubed multiplied by the second set, which is 10 cosine 10x. Then we will rewrite it as f prime of x equals to 4 sine cubed 10x multiplied by 10 cosine 10x. And since 4 and 10 can still be multiplied, we will simplify it and we get f prime of x equals to 40 sine cubed 10x multiplied by cosine 10x. So, this is our final answer. Thank you for watching, math learners. Once again, I am ROYALLENE BOLISAY from BSED 3D, and let's bear in mind that every problem has its own solution. Thank you for watching.